since operating system needs to manage all the processes inside the computer system. So that means the operating system needs to maintain some information associated with each process. So we call those information as a PCB, which is shorted for process control block. Here, all the information stored in the PCB is about the process from the perspective of operating system. So we also mention some information about the process, such as the text, the date, stack, and heap. So those information are from the perspective of process itself. So first is the state of the process, like we just talked about, such as ready, running, waiting, and terminated. And also, the operating system need to know what is the current progress of the process, which is stored in the program counter. The process may not be in the CPU, and the operating system need to know that. So before the process has been taken off the CPU, what is the process status? And that is why the PCB needs to maintain CPU registers. So when the process has been put back to the CPU, according to those informations, the process can be resumed and executed in the CPU. So in the PCB, we also maintain a CPU scheduling information. So when the CPU is available, the CPU will choose a process among all the processes with the ready state to execute based on the scheduling information. And also, we need to maintain the memory management information to know that, so how many memory space has been assigned to each process. And later, when the process finish the execution, the operating system needs to reclaim those memory space back, so make them available for other processes to use later. Sometimes the operating system needs to maintain accounting information. Who is the owner of this process? For example, so when the process wants to access some file, according to the accounting information, the operating system can decide whether the process has the right to do so or not. So when the process is accessing some file or doing some I/O, the operating system also needs to maintain I/O status information. According to the I/O status information, the operating system will decide that either needs to put the process into a waiting state or ready state. In this slide, we are going to talk about an example that how CPU switch from one process to another process. At the very beginning, process P0 is executing in the CPU. So when the interrupt or system call happened, so all the related information about the P0 will be recorded into the PCB0, as we have discussed in the previous slide. Then the operating system will be put onto the CPU and deal with the interrupt event or the system call. So after the CPU finish the interruption or system call, the CPU will run the scheduling algorithm to decide which process in the ready queue needs to be put onto the CPU next. Then process P1 is put onto the CPU to execute according to the information stored in the PCB1. A while later, some interrupt or system call has been triggered. All the information related to the process P1 has been saved into PCB1. Then the operating system has been put onto the CPU again to handle the interruption or system calls. Then run the scheduling algorithm again, so process P0 has been chosen this time. Then all the information about the P0 has been resumed from PCB0, and also the P0 has been executed in the CPU again. So during the idle time, the process will be switched to ready state, and put it into the ready queue. In this slide, I want to show that how the PCB has been implemented in Linux. Actually, the PCB is implemented by C structure, which is called task structure type. There are a lot of member variables inside this structure. So here we just list some of them so that you will know what kind of information will be in the PCB. So first is the unit identifier. So later when you do your own C programming, you will use it to manipulate different processes. The second one is a process state. So during the lifetime of a process, it will switch the states from time to time. Here, each number represents a state. For example, new, ready, running, waiting, and terminated. So each state will be represented by a number. There is an integer to track the time slice, which is called time slice here, and that is used for scheduling inside the Linux operating system. And also there is a structure pointer, so which point to the parent process. So later when you do your own C programming, you will know that the parent process is the process who create this process. And also there is a linked list to hold all the children that are created by this process, and also has a pointer to point to a list of files which opened by this process. There is another structure pointer which points to the memory address that requested by this process. And also each PCB structure maintains two pointers. One points to the previous PCB on the row. The other one points to the next PCB on the row. So we can see that all the PCB structures have been maintained as a double linked list. And also inside the operating system, we have a special pointer which is called current, which points to the current process that is running in the CPU. So you can see that how the information maintained for each process stored in the Linux operating system or in C. Each PCB has been maintained as a structure. So all the PCB have constituted a double linked list. And also we have a special pointer which points to the current process.